Question number 7 is to calculate osmolality from percentage solutions. First of all, what is the meaning of percentage solutions? Most of the time, when you have a percentage solutions, for example, 1% of NaCl solutions, that refers to weight over weight. That's the weight of solute over the weight of solutions. So 1% of NaCl solutions, that's equivalent to 1 gram of NaCl in every 100 grams of solution. So most of the time is weight over weight. But if the solute is in liquid status, when it's put in room temperature, then the percentage solution of this specific solute is volume over volume. We'll discuss that when we have those kind of solutions. Okay, to solve this type of questions, convert from percentage solutions into osmolality, I listed several steps for you. The first step is to determine how many NaCl are present in the solution. I'll take the first one, 0.1% NaCl solution for an example. As an example, so 0.1% NaCl solution is a weight percentage solution. It means we have 0.1 gram of NaCl in every 100 grams of solution. That is equivalent to 1 part in 1,000, right? Therefore, we should have 1 gram of NaCl every 100 gram of solution. That's 1 kilogram of solution. And we also mentioned that if the solution is very dilute, we can assume that the weight of solution, in this case 1 kilogram, is the same as the weight of solvent, which is water. So we can assume that in this case, in 0.1% of NaCl solutions, we have 1 gram of NaCl in every 1 kilogram of water, which is the solvent. The reason why I want to stress that is 1 kilogram of water, 1 kilogram of solvent, is because the final parameter that we want to convert into is osmolality. If you still remember, the denominator in osmolality is the same as the denominator of molality, which is 1 kilogram of solvent. That's why we want to convert the unit of the denominator into every kilogram of water instead of every kilogram of solution. Okay, step 2 is to calculate for the molality, which is the base of osmolality. When we have the molality, calculate for the osmolality will be very easy. Okay, the same thing. When we have 1 gram of NaCl in every 1 kilogram of water, we want to convert the numerator part, 1 gram of NaCl, into moles. 1 gram, we use that to divide by molecular weight of NaCl, which is 58.5 gram per moles. And the final number is 0.0171 moles in every 1 kilogram of water. And that is the molality of NaCl solutions in 0.1% solution. Step 3 is to calculate for the osmolality from molality. Since we already have the molality, we can simply multiply this number by the dissociation constant of NaCl. If you assume a complete dissociation, then you can use 2 as the dissociation constant. But here I'm using 1.8 as an example. So I'm not assuming complete dissociation. Instead, I assume 1.8 to be a more precise dissociation constant for NaCl. So we use the value of molality 0.0171, multiply the number by the dissociation constant that we assume, which is 1.8, we got the final number of osmolality for the 0.1% NaCl solution, which is 0.0308 osmolar. Step 4 is optional, but I suggest you do that because if you have such a small number of osmolality, it is very easy for you to miss a zero or add a zero somewhere in the middle. So I prefer to, when we have a very small number at the end of the calculation, I'll convert it into a smaller unit. In this case, when we have osmolar, I'm sorry, it's not osmolar, it's osmoles per kilogram. Don't know why I can't type, but it should be 0.0308. Okay, there's some problem with the computer, but it should be 0.0308 osmoles per kilogram, or osmolal. Okay, to convert that unit into a smaller one, I'll use milliosmoles per kilogram. So in the end, you'll have 30.8 milliosmoles per kilogram as the final number. I'll fix this when we finish the video. Okay, I closed the program and restarted, so I fixed this one. The final unit of this number should be milliosmoles per kilogram, and the number is listed here, 30.8 milliosmoles per kilogram. For the other numbers in this question, you can use the exactly same method to calculate them one by one, or you can use a simpler method. Since everything in comparison between 0.1% NaCl solution and 0.3 NaCl solutions are linear to each other. All of the calculations should be proportional. So you can simply multiply this number by 3 to get the final number, the final osmolality of 0.3% of NaCl solutions. And you can multiply this number by 5 to get the osmolality of 0.5 NaCl solutions. If you follow my calculations, the number will be the same. Similarly, you can have the osmolality of the other solutions. The answers are listed here. Part B of this question is asking which one of the above solution is closest to 290 milliosmoles per kilogram, which is the osmolality of blood plasma. From the number that we calculated, I'll say 0.85% and 0.1% of NaCl solutions are both the closest to 290 milliosmoles per kilogram. I don't know why they don't have 0.9% of NaCl solutions, but if they have them, 0.9 should definitely be the closest, more closer than either of these two. Okay, so that is question number 7.